Let's now look at solving some equations. This is sort of a unique situation, but you'll see this sometime where the equation has two terms, and as it turns out, they're both log terms. So here, to start with a very simple example, log base 4 of x equals log base 4 of 8 minus x. Now a couple things. First of all, in order to solve this easily, of course, you have to make sure both logs have the same base. Now in most of the problems, they will have the same base, but you never know if they might want to throw one in there to sort of stump you, where the bases on the logs are different. But assuming that's the case, and in this case there are only two terms in this equation, and both of them are log terms, then you can simply set them equal to each other, and then basically you set the arguments equal to each other. That's what we call x and 8 minus x. So basically, you can say for this equation to be true, the stuff inside the two logs has to equal each other. So you have x equals 8 minus x. Then if I solve this by adding x to both sides, 2x equals 8. And then I say x equals 4. Now you have to always be careful whenever you're solving an equation with logs. After you solve it, you always have to go back and check your solution. This is not optional. You have to do it. And sometimes what you may end up with is, of course, you can never have a negative number inside of a log. Sometimes a solution may cause that, or there are other things that may happen. So always have to check our solutions. So if I stick x equals 4 back into my original equation, I say, is this true? So log 4 of 4 equals log 4 of 8 minus 4. Of course, 8 minus 4 is 4, so I would say yes, it is true. And that confirms that this is the solution. Now, let's do another one. How about log base 7 of x minus 5 equals log base 7 of 6x. All right, same thing. This equation simply has two terms. They're both log terms. So we can simply set x minus 5 equal to 6x. I can solve for x, but please don't forget, I do have to check my solution. It's not optional. So how about if I subtract x from both sides? Looks like x is going to be minus 1. So now when I check my solution, I plug minus 1 back in for x. And I have minus 1 minus 5 equals log base 7 of 6 times minus 1. So on the left-hand side, end up with log base 7 of minus 6. On the right-hand side, log base 7. Now at first glance it looks like, well, yes, of course, they are equal to each other. But actually, even beyond that, according to the rules of logarithms, this does not exist. We cannot take the log of a negative number. And just to show you, to prove to you, if I try and convert that to an exponential, I would take, so just let me write it. So if I wrote it like this, I would say 7 to the x equals negative 6. And you look at that and you try and think of some value of x that would work, it's impossible. You can't take 7, you can't raise 7 to some kind of exponent and have it equal a negative number. So no, this doesn't work. So you end up saying no solution. All right, let's do one more that's maybe a little more involved. And actually we use natural logs. Sometimes natural logs get the short shaft, but let's do a natural log problem. How about natural log x squared equals natural log of 12 minus x. So once again, the equation only has two logs. I can set the arguments equal to each other. So I can say x squared equals 12 minus x. I can try and solve for x. This is actually a quadratic equation. So I'll move everything to the left-hand side. X squared plus x minus 12 equals 0. This is a trinomial of factors. Looks like 4 and negative 3. And then my solutions are going to be negative 4 and 3. If I quickly check those, maybe I can eyeball it. If I plug in negative 4 squared is 16. 12 minus the negative 4 is 16. That looks okay. The 3, natural log of 3 squared, which is natural log of 9. And I put a 3 in here, get natural log of 9. And it looks like those check out. So, when your equation simply has two logarithms with the same base, solution is pretty straightforward, except you have to remember, you always have to check your solutions.